Hello, sir. Can you hear me, sir?
Yeah,
Yeah, yeah.
you can see me as well, right?
Yeah, sir. Voice is little feeble.
Oh, really?
Now it is fine, sir. Now it is fine. Fine, sir. Yeah. We can see you as well.
Yeah, yeah.
Yeah.
I'm not using any microphone or, headphone or anything.
This is fine, sir. We can hear you. Yeah.
Okay.
Yeah. Thank you, sir. Thank you.
Okay. So, shall I log off or just be on mute?
Pardon, sir.
Yeah. Shall I log off or just be like this?
Sir, maybe you can, maybe video you can turn off because
The
we are,
video I'll turn off. Okay. I will turn on and I'll be on mute.
sir,
Okay.
we are planning to start in another 5 to 8 minutes. Yeah.
Perfect.
Yeah.
Thank you.
Yes.
ఇంట్లో ఉంటాను నువ్వే సైలెంట్ గా ఉండని అడిగి లెఫ్ట్ తీసుకోవచ్చు ల్యాప్టాప్
Professor Rofin, are you able to hear us?
Yes, yes, sir. Yes, sir.
So I think we can start this session.
Okay, thank you, sir.
Evening, Director Sir, Deans, esteemed faculty, students, and honored guests. My name is Tina Rikame and I'm one of the academic secretaries of IIM Mumbai. And it is my honor to welcome you to the panel discussion of IIM Mumbai and Intel at Abhisanskaran 2025 on the topic of strategic rise of data centers in India's knowledge economy. A rare opportunity to learn from visionary leaders who have shaped industries and inspired change. Today, as our nation marches towards Viksit Bharat, a developed, inclusive, and resilient India, it is our youth who stand at the heart of this vision. Their energy, idea, and ingenuity will propel this journey forward. Yet, to transform this vision into reality, we must build a strong digital backbone. And this is where data centers play play a pivotal role as the foundation of connectivity, high performance computing, and Gen AI. Data centers enable seamless service delivery across sectors and communities, making them vital to achieving the ambitious milestones of a shining and Viksit Bharat. It is in this spirit that IIM Mumbai and Intel Corporation have come together, a synergy that bridges academics, research, and industry to drive innovations that matter. IIM Mumbai has long been a thought leader in addressing complex, applied research challenges, and together with Intel, we have pioneered advances across supply chain optimization, digital transformation, HPC, and AI. This collaboration has not only solved critical industry problems for Intel, but also shaped global best practices, making it a beacon for research, industry collaboration, and purpose driven action. With that backdrop, here's how this evening unfolds. We will commence with a keynote address from Professor Manoj Tiwari and Dr. Radhakrishna. This will be followed by an insightful panel discussion featuring esteemed leaders Sri Goldie Mishra, Sri SMD Jalani, Sri Vishal Bharat, and Sri Sita Ramakrishna Nukala, moderated by Professor Sanjeev Verma. To conclude, we will open the floor for a question and answer segment, allowing for a rich exchange of ideas between the panel and our students. Let us now begin with an address by an esteemed and visionary director, Professor Tiwari, the founding director of IIM Mumbai since its transition from NITI in August 2023. Under his leadership, IIM Mumbai has risen to the sixth in the NRIF management rankings and embarked on an ambitious infrastructure expansion. A globally recognized researcher in manufacturing systems and supply chain management, Professor Tiwari has published over 400 peer-reviewed research papers, boasting an EDGE index of over 80, and has been honored with the IISE David F. Baker Distinguished Research Award. His contributions extend far beyond the campus, shaping national policies such as PM Gati Shakti and pivotal education reform initiative. We are honored to have him lead IIM Mumbai and privileged to have him address our newest batch tonight as our keynote speaker. Please join me in welcoming Professor Tiwari.
Thank you for giving me this opportunity to talk as a keynote on very important and very and very focused initiative which has potential to give a different twist to the economy. That is the strategic rise of data centers in India's knowledge economy. And today, among us, some of the leading experts whose voice in this particular field is quite authoritative. And we are blessed to have our,
Please settle down.
and we are blessed to have our own distinguished alumni here, Dr. Radha Krishnaji, Director Supply Chain Innovation Lab, Intel. And we are thankful to him for enabling to have a very good project from the Intel to work on such kind of topic. And our team is very much working timely actually to map the different developments of semiconductor mission of Government of India. And accordingly, we align ourselves with the given problems of the Intel, along with the also we are very much tie up with the Micron actually to do something pertaining to the supply chain of semiconductor components. In this respect, really, we have taken the huge advantage of our alumni base who are working in top-notch industries, and they are giving really a very timely service to the nation with regard to critical infrastructure that we need in the domain of semiconductor and semiconductor manufacturing and supply chain. So, for today's topic, as you know, the data centers are, one of the very essential element of building the intelligent processing of the data. And this is not only limited to one or two domains, but almost entire business gamut is being affected by the operational performance of data centers. And here I can say some of our leading experts who are here as a panelist, they are well known in their field, like we have Sri Goldie Bisraji, HPC AI expert, IIM Pune. We have Sri SMD Jilani, Director Operations, UIDI Bangalore. Mr. Vishal Bharat, Director India Operations. And Sri Sitaram Krishna Nukalaji, Senior Director, HPC AI Intel. So in presence of all this, deep-rooted and highly knowledgeable experts, I limit myself to very narrow aspects that how come this topic is so important for the growth of our economy. As you know that most of the components which are required for erecting data centers, they are like steel, a special type, aluminum of very light variety, but high caliber and high resilient type of material. Then we have many interconnected devices like switches, server racks, servers, cooling units, and many other, series of the GPUs that we need actually to do the many parallel processing of the data. And such kind of centers are very essential and need to be properly decentralized at different locations in the country, so that one very essential aspects of data processing, particularly in current domain of algorithm trading, that is a key component of financial engineering, where latency of the data processing is highly need to be discouraged. And when you talk about high frequency trading, in that case, also we need to have proper bandwidth of 5G and all others to support such kind of provisions that must be there in the data centers. So you can say a bright combination of hardware and software that we need to establish a data centers. Certainly in this advanced technology, you can't expect that all these things will be discovered, maintained, manufactured in the country in a span of just 4 or 5 years. This requires a long amount of research and then manufacturing provisions along with the assembling and several interfaces with the software, so that the interconnectivity and as well as interoperability among the components that need to be maintained among the many edge computing centers of the data centers, which are there not only in the major metros, but they are also going and jumping into the tier 2 and tier 3 cities also. So therefore, you can say to boost the knowledge economy, data centers are just like heart. And these hearts you can't expect to to debate whether the heart belongs to X or Y. We need it because our economy is propelling to the next level is more important. And as it usually happens in many smart technologies, something later at a gap of 15-20 years, they will be certainly everywhere. But initially, it will be the trademark of certain few top tier companies who want to maintain their all efforts in developing, shaping, investigating, and also what you call they have original ideas which they have put into bringing these components. So certainly they have all right to have their patent and to take advantage of early innovation in that field. So our idea is that we have to have a proper balance between them, and also the massive use of these data centers will certainly offset the cost of forex that we are paying for purchasing these items. And certainly efforts will be made to bring some of them to the India for manufacturing some of the units. And that way, slowly, our reliance over the hardware will also come to our side. So keeping in mind the different problems associated with the data centers, like how the energy consumption, greenness, and the kind of efforts to minimize the carbon footprint, net zero carbon efforts for operation of data centers. So they are almost to be taken care, but main focus is that how the operational domain of data centers need to be enlarged to many other domains which are not being covered, like healthcare, like high performance computing for the finance, and also in the domain of manufacturing, supply chain, logistics, warehousing, and many more. So I hope that the panel will discuss some critical and very important aspects of the data centers and its role in our economy, and several aspects of the operational positions of data centers. They will also be taken care in some way or another way in the formal recommendations come out of this particular panel discussions. With this note, once again, from on behalf of everybody in the IIM Mumbai, I thank to all my knowledgeable and very respected experts who are here for their kind presence, and hope that our budding students just who joined the MBA programs of all the three types in the campus, they will enjoy this new topic for growth of their career, and they also learn newer things by this discussion. Thank you once again for giving me this chance to have the opening remarks. Now I leave it to the experts to come out of with their own discussions and debate to take it forward. Okay, thank you very much.
Thank you, sir, for sharing your insights and vision. We deeply value the support of Intel, Micron, our alumni, and you to build this foundation for a brighter and more connected future. Also, sir, thank you for positioning IIM Mumbai as a thought leader at the very heart of this digital and knowledge-driven economy, a vision you articulated so eloquently and inspiringly. It is now my privilege to introduce our keynote speaker, Dr. Radhakrishna, Director of Supply Chain Innovation Lab at Intel Corporation. With over 25 years of industry and consulting experience across US and Asia, his expertise spans supply chain research, innovation, and digital transformation. Dr. Radhakrishna has worked with leading global organizations such as Intel, IBM, PwC, and Bharat Electronics, and served on the board of directors for the Association for Supply Chain Management, ASCM, from 2017 to 21. An esteemed alumnus of IIM Mumbai, Dr. Radhakrishna has been instrumental in fostering this collaboration between IIM Mumbai and Intel, making today's program possible. Please join me in welcoming Dr. Radhakrishna to deliver the keynote address.
Thank you, Tina. Esteemed Director, sir, panelists, professors, and my dear students. It's my privilege to be part of today's session, and I thank you for having me on this very important topic Intel and IIM Mumbai have a strategic partnership in the areas of research and innovation. So this topic is very apt in the context of the global economy and what are some of the challenges as we unfold going forward. We all know that there is an explosion in terms of need for data centers and the way it has evolved so rapidly. And as the global data center market accelerates, given by the explosive growth of cloud computing, 5G, AI, e-commerce, and all the data-intensive applications, one can quickly relate that it cannot be unconstrained. Like supply chain, there has to be some constraints. And we realize that while the demand for data center capacity may be limitless, power availability is not. So these are some of the challenges that in today's world, the whole industry, the data center ecosystem is grappled with. How do we really come up with creative options to do the balancing act? On one hand, we are seeing explosive growth with the GPT and AIML compute and use cases being taken up by enterprises, driving the need for scalable data centers. And on the other hand, some of the challenges facing the industry, reliable, sustainable power, etc. Now, as budding management students, it's not just enough if we focus only on traditional models like manufacturing, finance, traditional auto, pharma, healthcare, etc. They have taken decades to evolve to a certain stage of maturity, right? In this field of data center, it's happening so rapidly, and if you don't pay attention to it, we might quickly lose the whole opportunity. The train has left the station. Things are happening at breathtaking speed, and this has come not a day too soon. So I would encourage everyone to take a step back and understand the implications of what this means, because this is very disruptive and we can't just take it for given. We need the entire ecosystem to come together. Government can frame policies, but then everyone need to be coming together and making sure that we have a piece of the action, whether it's power providers, whether it's construction design firms, whether it's real estate, leasing agents, whether it's hyperscalers, power storage, management firms, sustainability providers. Just about everyone needs to be tapped into this. And for budding students, I would encourage you to understand the implications and come out of your comfort zone on just looking at finance or manufacturing, but see how this entire data center ecosystem will play out. What is going to trigger the talent to manage the rollout of this whole data center space? What is needed, and how are we able to manage this scale and this complexity? With that, I will transfer to the panelists. I hope there is enough discussion on this because we need to get our hands around this whole ecosystem, ensure that for India to prosper and hit the economy targets, we need a vibrant ecosystem, whether it's manufacturing, whether it's in rollout, deployment, just about everything centered around data center. And our challenges are one too many. It's not just having the capital to make things happen. As I said, power is just one example where we have severe constraints and we need to come out with creative options to manage that. But there's other policies, security, a whole bunch of other things also need to come together. And we need quality manufacturers at the ground level to ensure that the certification standards are all met. Then the HVAC providers, just about everything needs to come together. And we can't just assume that things will happen by itself. So it's a lot of work to do in a very short window of time, because it's the catalyst that's going to drive the economy. and we better keep our hands close to what's happening and encourage a lot of thought leadership, research, papers, contribution from the academia. And this topic should be very, very visible across all channels, and almost every month, every week, there should be some kind of snippet or news in terms of what's happening, what's not happening, whether it's influencing the government or the enterprise or whatever possible. This has to be discussed openly in a very transparent way, so that we're able to take advantage of the opportunities technology is providing. There are limitations in some areas we need to address, but there are areas where we can make progress. So we need to do that balancing act in terms of how far can we go and how can it translate into real benefits. If AI can give benefits through healthcare to our masses, what is limiting it? And not having a data center is obviously going to hurt, because you're not going to have all of that infrastructure and the setup in place if we don't have enough data centers. So it's the need of the hour to roll it out as quickly as possible, so that we're able to manage the explosion of data, we're able to manage the economy drivers, and support the growth of mature markets that have evolved over time. We do not have the luxury of another decade or two to wait until all this matures. Things are happening at breathtaking speed, and we need to catch up in a lot of areas. So with that, I'll hand over back to Tina for further discussion with the panelists. Thank you.
Thank you, sir, for shedding light on the explosive growth of data centers and the pressing constraints of power and infrastructure. Your keynote reminded us how this delicate balancing act, going beyond traditional models and embracing collaboration, is the key to countering disruption and shaping a resilient digital future. We're grateful for your insights and your vision. It is now my privilege to introduce our esteemed panelist, Sri Goldie Mishra, an eminent technologist and thought leader in high-performance computing and information technology with over 27 years of experience, currently serving as the Chief Technology Officer and Chief Information Security Officer at IISER Pune under the Ministry of Education, Government of India. He leads the Institute's IT department and has been pivotal in advancing India's supercomputing capabilities. As a core member of the team that developed Param series of supercomputers at CDAC, Mr. Mishra has shaped the nation's HPC landscape. His innovations, including acclaimed HPC software products such as eOnima and InClass, have earned international accolades, including the Global IDC HPC Innovation Excellence Award 2011 and the Manthan Award South Asia and Asia Pacific 2013. I invite you all to welcome Sri Goldie Mishra to the panel. Sri SMD Jalani, an accomplished technologist and public servant with over 27 years of experience in IT services across defense, scientific research, and national mission-critical projects. A pivotal figure in designing, setting up, and managing multi-petaflop, multi-petabyte HPC facilities at Indian Institute of Tropical Meteorology for the Ministry of Earth Sciences, Government of India. Mr. Jilani now serves as the Director of Technology Operations at UIDAI. Here, he leads the management of IT and non-IT infrastructure, UIDAI databases, and private cloud operations for Aadhaar, the world's largest digital identity program. It's an honor to have Sri SMD Jilani with us. Welcome, sir. Sri Vishal Bharat, Vice President of HPC, AI and Quantum at Evident India, with over 28 years of experience across the semiconductor and IT industry. Mr. Bharat is an accomplished business leader and a driving force in high-performance computing, AI and quantum technologies in India. At Evident, he leads the HPC, AI and quantum business, shaping its strategy, driving growth and expanding market share. Under his stewardship, Evident has delivered significant breakthroughs in supercomputing and AI, partnering with esteemed clients like Ministry of Earth Sciences, ISRO, and CDAC. Prior to this role, Mr. Bharat led Mellanox Technologies in India until its acquisition by NVIDIA in 2020, making it the go-to brand for supercomputer and AI interconnects. He was also pivotal in initiating Mellanox's manufacturing in India, making it the first and only company to produce high-end networking equipment domestically for global distribution. Let us all welcome Shri Vishal Bharat to the panel. Shri Sitaram Krishnanukala, an eminent technologist and veteran of high-performance computing and AI with over 3 decades of distinguished experience, currently serving as the director and geo lead for HPC and AI solutions at Intel Corporation. Mr. Nukala is responsible for architecting complex HPC and AI data center systems across Asia Pacific and Japan region. In this role, he guides and mentors end users and partner communities to build state-of-the-art on-prem and cloud HPC AI environments. Prior to Intel, Mr. Nukala was instrumental in creating and leading the HPC and data center services practices at TCS, serving global manufacturing giants like GE, Procter & Gamble, J&J, JLR, and Ferrari. Earlier, as program director at Tata CRL, he led the team that delivered the world's fourth fastest supercomputer, ECA, in 2007 and pioneered its use for cloud HPC services across aerospace and automotive, energy, space, and other industries. Please join me in welcoming Shri Sitaram Krishnanukala to the panel. Today's conversation is an opportunity to rethink how data centers can catalyze growth and drive digital empowerment across sectors and communities. Let us listen, learn, and engage in this vital dialogue about building a resilient, inclusive, and future-ready knowledge economy for India. And now it is my privilege to introduce our moderator for the evening, Professor Sanjeev Verma, a distinguished faculty member at IIM Mumbai with a deep expertise in marketing, analytics, and business strategy. As an educator, researcher, and thought leader, Professor Verma has shaped the next generation of management talent, combining academic rigor with rich industry insights. His experience and perspective bridge technological innovation, business acumen, and policy thinking, making him the ideal guide for today's discussion. Please join me in welcoming Professor Sanjeev Verma, who will now steer this conversation and help us unpack the role of data centers in shaping India's knowledge economy. Thank you and welcome once again to this encouraging and thought-provoking session. I now invite Professor Verma to commence the session.
Thank you very much, Tina. Namaskar and good evening to all. It's my privilege to moderate the session today, and I can see the galaxy of intellectual stars who will have very enriching discussion on the theme. But before I begin, so we have been hearing that data is the new oil. But unlike oil, I believe value does not lie in the scarcity here, but the value lies in the abundance, accessibility, and the intelligence which we extract from the data. Data itself is inert, but as Director Sir was mentioning, the beating heart is the data center. They store, process, distribute. And in the present business environment, which is very dynamic, intelligence depends on the kind of data which we are handling in the real-time basis. So would like to really understand how this industry, is evolving. And as you know, the importance of data, how data centers will contribute to the growth of the economy. Now, the important themes which has emerged from the keynote speakers, Radhakrishna ji and our esteemed director, sir, is about the need of strong infrastructure, sustainability aspects, scalability, the sovereignty, the data protection, the ethical guidelines, and where we all can come together, to collaborate to really harness the power of data centers. So let us begin with the discussion, and I'll be starting with the most foundational question around the data center is about how infrastructure act as a catalyst to the growth of this sector. So how data centers are transforming the passive infrastructure to become an active enabler for innovation, intelligence, and inclusion in different domains. So I open the floor for your reflections, and we can start with Mr. Jilani, and then we can move on to the other experts. So Mr. Jilani.
Am I audible?
Yes.
Yeah. So I thank IIM Mumbai for this invitation. So coming to the question, how data centers are enabling the things. So basically, the way I look at it, when we talk about data centers, there are two components to it. One is the IT part of it, and the non-IT part of it. So the IT, when we say, I mean, more or less, we have a visibility of how technology is evolving, how newer systems are coming in, be it the x86, be it the CPUs, or be it the GPUs or the storage technologies. We have a fair visibility for years ahead, what would be the growth. Of course, this was very clear till the time GPUs were not there in that factor. Introduction of GPUs has actually disrupted the planning of the data centers, to be very honest. Now, coming to the non-IT part of it, like Director Sir was earlier mentioning, there are only two components, the way I look at it. One is the power, the cooling. Of course, the real estate and other associated components goes with it. So when we plan about data centers, we have to think, when we plan about IT, we think about the IT life cycle, let's say 5 years, 7 years, or 8 years. But when we plan about data centers, we have to think about few decades at least, so that we accommodate at least 3-4 technology cycles as part of ongoing process. We cannot keep on building new buildings. We have to have enough buffer capacities to accommodate newer technologies. So how this has contributed to the economy? Let's take our case, for example, Aadhaar. So Aadhaar started somewhere around 2012. So the moment, I mean, after Aadhaar came into, has enabled the country. So the rate at which the residents have got the bank accounts, the rate at which the DBTs have, I mean, billions of dollars have been saved. The middleman has been eliminated. The onboarding of the customers, the entire ecosystem, at the core digital India, Aadhaar has enabled the digital identity, and it has enabled, I mean, there are statistics, I mean, available in the public domain. So now when we talk about other data centers, we are not just planned for 10 years or 20 years. We have sufficient capacities to take care of for at least a couple of decades ahead also. So non-IT has to be planned with a longer vision. IT will keep evolving. It's very fast. Every six months we see new processes coming in, new technologies coming in. So with Aadhaar as an example, how it has disrupted or how it has actually contributed to the growth of the economy can be a classic use case on how data centers contribute. I hope I answered your question. Sorry, I'm not hearing.
Okay. Am I audible now? Okay. So, Mr. Jilani, I bring the leaf from your discussion that data center broadly, have two kinds of structures, IT and non-IT. And basically, the structures are meant for the inclusivity when you give the example of Aadhaar, and we need a long-range planning. So now I go to Mr. Goldie Mishra to understand how the research, academia, the future planning can help us to really build an infrastructure which is robust enough to take care of at least 5 decades or a century. Over to you, Mr. Goldie Mishra.
So, yeah, thank you for inviting me. So I would like to first highlight that this sudden exponential rise in data centers, the catalysis has happened in the last couple of years in a very big way in our country. The major contributing factors are the rapid digitization, which is happening across most of the sectors, in fact, all of them. High performance computing was traditionally one of the areas, but now the application layers such as the artificial intelligence or cloud computing, machine learning, or any kind of AI-driven analytics, data analytics, which is happening, is another contributing factor to the exponential rise of the data centers and corresponding businesses thereof. So Luckily, I would be very happy to say that by and large, we have a great, excellent communication infrastructure. That is the core backbone for connecting users and corresponding data centers. And faster adoption of 5G has enabled a lot of clients and end users to directly connect to various services being availed through these data centers from the user end. That is a very big advantage, and that is where the mass comes in. Then, as rightly pointed out by Director Sir, that there is a huge demand of power, but there is a lot of effort by the government by way of renewables. And for example, there are solar energies being used. So when now data centers are being designed, large scale data centers, solar energy is being factored as one of the contributing power input elements there. Then cost effectiveness of a data center ecosystem in our country is much better if we compare that to the other regions globally. That is a very key point wherein you will find a lot of impetus being given to large data centers in our country. And there are a lot of ongoing huge amount of investments in the hardware. So, which is the basic building block of these data centers and which serve as the core element in all these data centers. As rightly pointed out by my colleague Jilani, finally this IT part, the transitioning of new technologies is ever increasing, ever evolving, and industry is producing and innovating at a very fast rate on the hardware front. There is a lot of activity still remaining on the software and the application front. So the application has to be more society oriented in terms of actually solving ground reality problems. So that a lot of focus has to be put in. So now data centers being the heart, as rightly pointed out, heart of the entire economy, is because they've become a very important business activity, and it has now it's becoming very close to becoming a national asset or a national infrastructure. So very soon you'll find many of the data centers being declared as national assets and or critical national infrastructure. So now with this, the skilled manpower, the education of manpower, and deployment of managing such large data centers, in addition to application enablements. So application enablement around these data centers is the very important aspect, wherein people are not available right now in this country, wherein applications can be enabled across such large platforms on such a large scale. So that is another area which has to be looked into very strongly. So global market, we are expecting on the data centers annual growth in the next 3 to 4 years is 27 CAGR, 27%, which is pretty high in terms of this industry segment. So just to give you an idea, right now, as you mentioned, manufacturing, civil, the traditional, as rightly pointed out by Dr. Radha, that a lot of traditional activities and traditional markets and traditional factories, companies, and trades were going on. But right now, the trend is ever evolving in terms of every now and then we have a new change. It's largely enabled by the cloud service providers such as AWS, Microsoft Azure, Google Cloud, and a few more. Then internet service providers are also there, such as our Airtel, Jio, VI, and large scientific data centers also are there. The ISRO, CERN, DRDO, and their affiliated centers, which are addressing the needs of a lot of users in a big way and trying to accelerate research and innovation. Then we have financial markets, as rightly brought in by Director Sir. So the core facilities of financial markets are very much dependent on large data centers, and the data centers also keep evolving in a big way, such as NSE, BSE, the Clearing Corporation, and the banking service, the financial the banking, core banking, that is back-end operations of large banks for core banking solutions like SBI, HDFC, ICICI, so on. So just to sum it up from my side, from the education and skilling perspective, this area is very important, and there is no dearth of requirement of manpower in this area, right from the core fundamental of managing, of being part of establishing data centers, to managing data centers, or the application perspective of such large facilities. And there is a lot of scope for IIM graduates to participate in such kind of roles, because see, IIM graduates have a typical advantage of having management or a business perspective in addition to technology. So that's a unique combination which helps them, and they play a very strategic role in such large scale operations, because see, data center or any of its allied uses or applications are very large scale, and sky is the limit, as rightly mentioned by one of the panelists earlier. So with this, I would like to request Dr. Sanjeev to take it.
Thank you very much, Professor Mishra. Very enriching insights. And you are right in saying that digitization is the game changer, which has really turned around the industry. And really, the data centers are becoming the nervous center or the heart of the entire economic growth. So you touched upon the various technological aspects, for example, HPC, application layer, AI natives. I moved to Asita Ramakrishna ji to understand how the industry giants like Intel is reimagining the role of the emerging technologies like AI natives and HPC optimized architecture to really change the game. Where are we heading to?
Yeah, hope everybody can hear me here.
Sir, you are audible.
Yeah, thank you very much. So thanks for inviting me for this panel, and thanks Director Sir, and then the professors, and then Dr. Radha, and then my co-panelists here for sharing their views. And certainly Intel being, compute everywhere, that is ranging from your mobile devices to the data center, it plays a key role in addressing this sector's requirements. Yes, Intel itself runs very large data centers for its own design requirements, and it's been evolving for last 25, 30 years at a speed that, the user's expectations we are not able to meet. It's not in a, Intel engineers are, the so-called great rocket scientist kind of a thing. We also have been always in a catch-up game with end user expectations. And for these purposes, the main thing is that the power is the biggest criteria here. If I do not reduce the power that is required for the data center, whether it is one server or 100,000 servers, so the data center growth and then the knowledge economy will come down. It is like, comparing to the mileage of a vehicle, automotive, or, comparing the aeroplane, how much fuel it can consume. If I don't reduce these two things, the way that automotive sector or a transport sector suffers, the data center and indirectly the knowledge economy, which is depending on data center, will suffer, because the data processing requirement per bit, the process cost will go high. And once it goes high, it's not relevant for the any kind of economic benefit. Anything that as management institute, you are better aware that everything need to be balanced. It cannot be that one factor of a society can dominate the other factor, and it need to be balanced across everywhere. Today, with directors are also referring that the power is the one big challenge that we are facing in the data center industry. And this power, if we are not able to reduce, it's going to consume a very natural resource, whether it is solar, whether it is wind energy, whether it is going to be a hydro energy or nuclear energy kind of a things. Just to say that, Reliance is building 1 gigawatt data center at Jamnagar. And imagine 1 gigawatt, each house will have 5 kilowatt is a max that we consume. And 1 gigawatt is so much of a high power that is required for one to 5 years within India. And if this is the case of India, already, the world is growing. The US, Europe, Japan, Korea, and these guys are trying to compete. They are aware that how much is this energy is going to cost to them and how to bring down this energy cost, and then per se the data processing cost. So as you rightly said, Sanjeev ji, this has been a major issue that is identified by Intel. And as part of its effort to bring the cost of operations down, what we need to pack is that compute power in highly small kind of an area. That is, the transistors which are working at creating this compute power, those transistor sizes have to be reduced, and the power that we consume per transistor, which is so much it controls when it becomes millions and billions kind of transistors that work across the globe. Multiple trillions transistors will be working from your laptop to mobile phone to everywhere. What is the main source of this power consumption? Is your transistor. The smallest component in your data center electronics is the key culprit in consuming this. So that's where that Intel is investing heavily, roughly around $100 billion, in creating much lower nanometer transistors, which I am roughly using it as in relevance to transistor, but actually the nanometer refers to the P and N gates, the distance between these two. But for a common purpose, I can say that per transistor, how many nanometers I can take. So that has been the mandate of Intel. And today I can very positively and proudly say that from nanometers to today, we have evolved to the measuring the transistor size into angstroms. I started my career maybe 100 microns kind of in a size, and from there we went to 1 micron. Beyond this and other these things, but thanks to the researchers, all computing is nothing but thanks to the physics behind the thing. I am sure Goldie Mishra and then the Jilani and then my friend, from Evident will appreciate that, though the compute is in front, but back end of compute is nothing but the basic science, that is the physics. And if the physics is not there, nothing is going to work here. So Intel, though it's seen as a compute company outside, I'm making, processors and other these things. Its genes are into manufacturing and then the physics excellence. So with this physics excellence, we are able to reduce the power to much, much lower. And Intel is very well known that, double the performance at the same power in every year, every 2 years. That is the Moore's law that, we have gotten. And that Moore's law also, we are able to increase the power twice in every couple of years. But of late, because of the AI requirements and because of the high performance computing requirements and the data need to move so fast, combined all these things, we are also struggling to reduce the power consumption for the transistors. And the day that, we reach to the picojoules of power, or 1 picojoule or 2 picojoules kind of a power per transistor, I think we will see much better economic data centers coming over across the globe. Today, in fact, these discussions are happening in the American Parliament, in the European, law houses and Indian law houses, that, if data centers are taking so much of power away, then how the common man will survive. And the second question is sustainability, as Professor Verma you shared, and then the director shared, how this earth is going to sustain if you are transforming energy into pumping into this large, whatever the knowledge, it can be processed, but it need to be processed at an affordable kind of a thing. So Intel's major focus is provide a sustainable, scalable, and affordable compute by investing into physics and then reducing the transistor sizes and reducing the power consumptions. Of course, the compute is byproduct of this. Physics is the major contributor in these things. Anything that you take, light of speed is measured because of physics. The power is measured. Our life is physics. So here I would say that no, Intel is heavily investing in its physics scientists and then the processes that to be developed. Hopefully we beat sometime the user expectations and then go ahead beyond even what user is expecting.
Yes, very true, sir. What you said has touched the code, what's going on in my brain. And you're right, data is everywhere. It's humongous. The demand for the data center is going to exponentially increase. Our dependency on data is very high because you want to generate intelligence in the real-time basis. Now, where is the solution? The power is which we require to run the data centers. There are resource consumptions. So the challenge lies in the sustainable scalability. And we have another friend, Mr. Vishalji, who is an expert and leading many projects in quantum computing, HPC, AI infrastructure related initiatives. I wish that Vishalji should throw some light, how can we tackle this balance, performance as well as sustainability. So Vishalji, please guide us.
Thank you, Sanjeev. And I would like to thank Professor Manoj Kumar, along with Dr. Radhakrishnan and my fellow panelists. Thanks for giving me an opportunity to speak on the subject of data center. How does it come to the economy? If you look at the present situation, as you said, as Sita said lastly, that energy becomes the key issue for any data center. If you look at the present situation, which is happening, the present data is that at present we are consuming, America is consuming around 445 kilowatts of data for the next in 2024. But this is to be almost doubled in the next 5 years. Because as we said, data is a key, so data center becomes the key, most important part to where we hold the data, As evident, what we are focusing on is how do we save the energy and do the best out of it. So in the present scenario, I would say that we have to take energy consideration into consideration. We divided it into 4 different parts. So there are 4 types of data centers which are being used in the government or being used. The first one is the large government sovereign labs, where we have very large infrastructure. We have UADI, we have the Ministry of Earth Science, where we are almost putting up almost 5,000 of the servers. We have the CDACs of the world. The second one is the large, what you call the hyperscalers. We have Google's, Amazon's, Meta's of the world, who have put up large infrastructure here in the country or anywhere else in the world. And same thing goes with an enterprise customers like the Reliance, Airtel, and other telcos who have a huge data centers. And the last one is in education sector, where we do all the basic research into these data centers. So unless and until we don't start moving this data center and making it run in a most efficient way, it is not going to sustain for a very long time. So what evidence does it that we have the basic infrastructure for a data center is how much kilowatt of power is being used to run a data center. Suppose if you are using there are 5,000 or 4,000 servers in a data center, you will need a 1 megawatt of power. But to use 1 megawatt of power, you need another 50% more. That is 50% more power to cool this infrastructure. Otherwise, it will not possible. So we at Evident are running the data centers at a PUE where we say the power utilization factor of 1.05 or 0.007. So that means only 7% instead of 50% of more electricity, we're only using 7% more electricity to cool the data center infrastructure. And the best, that is one part of the story. And we do it by using a technology we call it as a warm water cooling. Normally, all the data centers which have been used here, you have put a large chillers outside the data centers. But that is where we do the cooling of a chiller. You require the cooling of the structure. What we do is we utilize a normal 40 degrees inlet water temperature to cool the data center. So you don't require a chiller to cool it. So your energy efficiency becomes very less. And second thing, what we do is that we accommodate a lot of servers because data center servers becomes a key. And we accommodate a lot of data centers in these servers into a single rack. So we space normal consumption is you get a rate the rack where the data servers are kept are in the range of around 10 to 15 servers. But where within Evident, we do almost 100 servers in a rack. So you are both as a sustainability and energy efficiency, you are reducing the power utilization and you are splitting the space in that segment for this. So this is where we come into the picture of the data center. That's why our net zero sustain goal is by 2025, we should be, as an Evident, we should be net zero. And we think India is also looking at by the year 2047, we should be the net zero country for the world.
Appreciable the initiatives which we are taking at the Evident, and you're becoming and setting up an example, the inspiring model, how we can work both the scalability and the sustainability altogether. Thank you very much on your reflections. After talking about the power consumption, sustainability, and the infrastructure, a very important dimension related to the data center is revolving around the sovereignty of data, security of data, and the trust factor. So I wish that our experts should reflect on how we can ensure the data sovereignty while maintaining interoperability, trust, and resilience in the public and private data center infrastructures. So I open the floor to the experts. We can start with Vishalji first, and then we can move on to Sitaramji, then Goldiji, and Jalaniji.
Yeah, so sovereignty of the data is again one of the very key things for moving forward, because unless and until the data is not kept within your premises, your premises means within the country which is the sovereignty of the country, because it is a key. You must have seen that all at present in the latest what we have heard, the wars, people can directly inside get into your grid and start disturbing your full electric programs of the countries. Unless and until it's not fully sovereign, it's not fully been secured, it becomes very difficult to do it. And the second thing is, if you take out the latest the skirmish which happened between India and Pakistan, Operation Sindoor, it was totally the first digital war, we can say, whereas there was not a single person has moved from our country to the other country. It was being all played using the missiles and the data which we are intercepting, and we are intercepting the missiles at one another. And that could only happen because we have the sovereignty and we have to keep the data within our country to use it. So that's what I said, the sovereignty of the data becomes a very key important going forward. And that's what my point is.
Very true. Jalaniji, UI/DI is handling a lot of public data and data privacy, data protection, data security, building trust are really the daunting task. So I wish your reflections on this.
So yeah. So basically it comes from classification of the data in the first place. So we have to classify what is important, what is private, what is shareable, what is public. So it comes from there. Now, thanks to Government of India, the legislation is also enabling. All of us might have heard about the recent DPDP Act. So the PI data, the personal identity data, that has been classified as the most, it's private to every individual. My data is my data. But my data is available with my consent on various platforms, be it Facebook, be it Google. They're having some of the other information of mine. So they are also made responsible. Everybody who's processing the data is one or the other way is made responsible for securing the data by legislation, and there are heavy penalties which have been talked about and hopefully will be implemented. Now, coming back to again, the sensitivity of the data, not just the demographic information of it. Now, if we talk about UIDS context, we are dealing with biometric data. So biometric data is its core biometric. So it can actually, impersonate one person to another person. So coming back to sovereignty comes with the security, multiple layers of security, how tightly we keep the data protected. If it's classified as a not shareable, completely private data. So the security plays a very, very important role in terms of securing the data. At the same time, there are other use cases. In my previous experience, when I was working with Ministry of Earth Sciences, the problem we were dealing with the problem of climate change and monsoon forecasts and so on. So that is not a localized problem. That is a global problem. I cannot improve upon the science of the monsoon just by working on the data of India. I have to consider the entire globe's data. So their data sharing, collaboration, everything comes in play. So it all depends upon classification of the data and then building security layers on top of it. I hope I answered the question.
Yes, absolutely. So, I believe ethicality and responsibility are the key words in the present time. I wish that Goldie should reflect on what are the ethical governance framework or regulatory framework we should devise, to take care of these aspects. Goldie, your reflections, please.
So, thank you, Sanjeev ji. See, actually, data center, originally, if you look back about a couple of decades back, there was this supercomputers were very strategic in nature, and then denials and all these import regulations and restrictions and all those things were in place, specifically because they were considered as dual use technology. Dual use technology means that it can be used for civilian and societal purposes. And at the same time, it can be used for strategic defense purposes. So now what has happened is, in the recent years, as rightly mentioned by one of our panelists, you will find that data center and the entire ecosystem now is a full of dual use technology. Now, dual use technology there has to be a very fine balance between civil use and strategic defense use. So all these data centers can host. So earlier it was traditional, a data center or a supercomputing used to just maintain a nuclear stockpile. And that is how it became strategic in nature. And come now 2025, and in fact, the last 5-7 years, you will find that everything around strategic nature of defense and mechanisms, any innovation around sovereignty of the country is dependent solely on data centers, be it research or any of these innovation, various designs, and all these implementations have to be done finally on data centers. Not only maintenance of nuclear stockpile now you will find that data center is a key element in the dual nature of the entire activity. So coming back to your exact point of legislation, the government is trying to come up with a lot of rules in terms of data protection, as well as defining, as rightly mentioned by Jirani ji, defining what is private and what can be public. So a lot of rules coming in, and drafts are out, and after that the legislations are also coming in place. See, it's the since this technology is also ever evolving, the implications and the applications are also ever evolving. So every now and then we find new kinds of applications around AI, for example, or the models being improved in such a way. It's not that it's going to take some months. You will find every new day, you will find some new model performing better than the other. And see, with this, then even the legislation, framing of rules and policies. So for example, various policies across various sectors. This is an ongoing process which has to be kept in mind and has to be ever evolved. So it has to be just to be abreast of the technologies and the related applications. It has to happen continually, and that is what my opinion is. Thank you.
Yeah, thank you very much, Professor Mishra. I believe we are running short of time, but I would like to take one last question, which is, I believe, is extremely important for us to converge, because this theme is multidimensional, and as Professor Mishra was mentioning, applications and implications are multifold. So it means we need everybody, to come together to make it success. So I would like to ask Sita Ramakrishna ji to please help us to understand how we can bring various stakeholders, including academia, industry, government, together on a single page and drive this growth chapter forward.
Yeah.
Sita Ramakrishna ji?
In fact, sorry, I was speaking on mute. So Professor Verma, you touched the very close to my heart this subject is. Frankly speaking, we are seeking IIM help, the management help, to arrive at a kind of a framework where, there could be all this cross section of people can come together and then contribute and then come out it. If you ask me, I will give you lots of theoretical bookish knowledge about the sovereignty, about the security, about the ethics and other these things. Who am I? I am fundamentally a technologist, but unfortunately, I'm not an expert of ethics. I'm not an expert of anything. Yes, rightly saying that no, we need to get these experts, whoever are there, or historians, or
We lost your voice, sir. It seems there is some signal problem. Sita Ramaji,
upcoming technology and how we can get cross section of people together and then manage these data centers.
Yes. Yes. Thank you very much, Sita Ramaji. I believe we are running out of time. Do we have time for student question, or shall I? What do you suggest? Okay, we can take 1 or 2 questions at max. So, sir, we are opening the floor to the students now to ask if there is any question from their side. So we can start with the auditorium. Any question by any student in the auditorium to our experts?
Hello.
Yeah.
Hello. Good evening, everyone. My question is to Professor Goldie Mishra, sir. Sir, what are the unique challenges and opportunities that exist when one is managing a high performance computing for in an academic environment versus an enterprise environment?
So, good question. See, on the basis of uptime. So there are different tiers of data centers which are built. Now, it all depends on the applications they have to be served. So this is thought of at the inception stage of building the data center. So if in education you have a tier 3 or a tier 4 data center, just because it caters to a large group of institutes. For example, we are one of the NSM sites. IISER Pune is one of the NSM sites. That's the National Supercomputing Mission sites, wherein about 25 to 28 institutions use the supercomputing facility for their HPC and AI jobs. So that becomes a very critical nature, because there are a lot of publications, a lot of research, a lot of projects also dependent on these. And you would be happy to know that there are also users who pay for the facility on a per minute or a per core or a per hour basis, depending on the GPU or a CPU. So if you look at the nature of, you can't say that enterprise requires 24/7. In fact, data center means 24/7 by 365, be it in the education, research, academia, or enterprise. So how the data center is built is very important. That is how it serves the entire set of users accordingly. I hope I've answered your question.
So we can take one last question. Fastest fingers first. We have various rooms, LH1, LH2, LH3, classroom number 315. Only one question we can take.
Hello, sir. My name is Kalp. I'm speaking from the auditorium. My question is, how do you manage, my question is to Mr. Jalani. How do you manage the massive scale of the Aadhaar data in terms of security and citizen privacy?
Okay, so a lengthy answer, but I'll try to keep it short. So basically, if you talk about Aadhaar, there are two business use cases. One is onboarding somebody onto Aadhaar platform. That means we giving an Aadhaar number after collecting some information. That's the onboarding process that we call it as enrollment. And second use case is the authentication. Post onboarding, whenever you want to prove yourself that you do an authentication in the form of biometrics or in the form of OTP or in the form of face, or if you go into a bank to open a bank account, you do a KYC. So that's a second use case. So one, we onboard, and second is we authenticate. Authenticate is our product and onboarding is our process. So now, when we collect the information in the first place, right from the enrollment center you walk in, the data, once it is keyed in, that is an in-memory operation. From once you get an acknowledgement slip, from there, that point onwards, the data is not readable. It is double encrypted with public keys and private keys, even in transition and even at rest. So that is one part of it. So the encryption secures that data is not readable by anybody, anywhere. The only readability comes from internal core applications of the Aadhaar. So that is one part of it, how secure your data is. And the second part is securing the data through the security framework. So with that, these data stores are never exposed other than strictly for internal data processing purposes. So with that, be rest assured, so far, touch wood, the data is secure.
Sir, thank you very much. And it has been a very intellectually enriching session. We explored various strategic, operational, and ethical dimensions around the data centers. Although the discussion were very, very deep and insightful, but let me bring out the core points which has emerged through the discussion. So our discussion reaffirmed that data centers are no longer passive storage facilities. They are the critical enablers of real-time services, scientific discovery, and digital innovation. And we all agree that the data sovereignty and cyber resilience is the need of the hour. We touched upon the infrastructure and sustainability paradigm balance, and we have to see how we can scale, keeping in mind the ecosystem and the environment at the same time. And finally, we thought of how we can bring everybody together on the same page to build a inter-institutional collaboration and build a digital workforce. And I believe that this topic is a very vast topic, and 90 minutes discussion is not enough. We may continue our dialogue in different formats, maybe some more discussion rounds on the same theme. But my final reflections are that how many data centers India should build? What is that limit? Because I believe data is everywhere, and this is something which is, I believe, infinite opportunities exist there. The next question arises, what kind of data centers we should build, for whom, and what are our core values? Because it's a very, very critical function in the present time, right? So will they be AI natives, but at the same time, yet transparent mechanisms? Shall we think of sovereignty, but yet interoperability? Are we talking about the efficiency, but what about the inclusivity, right? So these are certain things we have to really deliberate on, think on, moving forward. I extend my heartfelt thanks to our distinguished panelists for sharing their deep domain knowledge, and to our audience for your thoughtful engagement. Let us carry forward this momentum across institutions, sectors, and geographies to ensure that India data centers becomes engine of knowledge, equity, and global leadership. Thank you very much. And I hand it over to our comparer for today, Tina. Thank you very much for the opportunity.
That brings us to the end of an enriching and thought-provoking session, one that sparked new ideas and inspired bolder thinking. With that, I now invite Professor Roffin for the vote of thanks.
Thank you, Ms. Tina. So good evening, everyone. So as we bring this deeply engaging and insightful panel discussion to a close, it is my privilege and honor to deliver the vote of thanks on behalf of IIM Mumbai and the organizing team of Abhisanskaran 2025. So this event marks a significant collaboration between Intel and IIM Mumbai, and we are grateful for the extraordinary participation and thought leadership that shaped today's discourse on the strategic rise of data centers in India's knowledge economy. To our esteemed director, Professor Manoj Kumar Tiwari, we extend our heartfelt gratitude for your unwavering support and visionary leadership. Your belief in the power of academia industry collaboration continues to inspire us. We are especially thankful for your insightful keynote address, which offered valuable perspectives and set a compelling tone for the event. And a special note of thanks to Dr. Radhakrishna. Your thoughtful remarks laid a strong foundation for today's discussion and enriched the deliberations with depth and clarity. You have reinforced the need for catching up with the breathtaking speed at which this ecosystem of the data centers are evolving, and how these data centers are going to be a catalyst that will drive our economy. Further, we are extremely grateful for you to being instrumental in forging this collaboration between IIM Mumbai and Intel. And Sri Sita Ramakrishna Nukala, Senior Director, HPC, High Performance Computing and AI at Intel. Sir, your inputs on the power consumption of data centers, how transistors are moving from the scale of nanometers to angstroms, and what is the Intel's strategy, or maybe the corporate strategy of having sustainable, scalable, and affordable compute by investing in physics, was truly insightful. Thank you, sir. Sri Vishal Bharat, Vice President, HPC, AI, and Quantum at Evident. Sir, your thoughts on how Evident is reducing the power consumption by a new technology like a warm water cooling and the server density, and further your insights on the sovereignty of the data were also very enriching. So thank you, sir, for your inputs. Sri SMD Gilani, Director of Technology Operations at UIDAI. Sir, your thoughts on how the two parts of the data centers, that is IT and non-IT, how they should be treated separately, such that non-IT should be planned for a longer term and IT is evolving. Sir, this was really enriching and insightful. And also the critical role of data centers in large-scale government projects like other project. So that was also really eye-opening, sir. Thank you very much. And sir, Mr. Goldie Mishra, CTO and CISO at ICR Pune. So thank you, sir. Thank you for your inputs on the drivers of data center growth like rapid digitization, AI, ML, and how solar energy or other renewable source of energy will be driving the DCs that will make it more sustainable, and how the DCs will be critical national infrastructure. So your insights were truly deep, sir. And again, our moderator, Professor Sanjeev Verma, for weaving the conversation together seamlessly. Sir, thank you very much. Your questions brought out the very best in our panel. Thank you, sir. And I also take this opportunity to thank our compere, Ms. Tina, and all the dedicated student coordinators whose enthusiasm, efficiency, and tireless efforts behind the scenes were instrumental in the smooth execution of this event. A sincere thank to our my faculty colleagues, Professor Debabrata Das, Professor Jashashi, and Professor Rosalind for their constant support, collaboration, and the contributions at every stage of planning and implementation of this insightful panel discussion. So your commitment to excellence ensures the success of such initiatives. And to our incoming batch, last but not the least, the discussion was curated with you in mind. I hope today's exchange sparked your imagination, widened your perspective, and encouraged you to think boldly about where management meets technology. Thank you very much. Thank you all once again for your time, attention, and participation. Good night.
Thank you, sir. With that, I now formally conclude the session. Thank you once again. Now may I request everyone to turn on their cameras so we can capture this in evening. Okay, thank you very much.